Hello student, today we are going to study data cleaning techniques and data transformation. Data cleaning is one of the very basic steps that we must start with before doing anything with the data warehousing. As we all know, data warehouse is a collection of collect data from the different heterogeneous sources available far away at different remote sites. And in the start, every data and data heterogeneous database has its own schema, and they vary from one system database to another database. And as the data warehouse is collecting data from the different sites locations and it's storing on the integrated data, the data schema that is designed at the data warehouse is quite different from the different schema available at the file locations. So there situations may occur in which we do not have any proper column or proper data to fill in proper locations. So this kinds of missing values create a lot of problem if we do not fill it properly before doing our transactions. So this filling the missing values is one of the very important state condition before doing any data processing. So what are the now we are going to discuss what are the basic techniques for the technique used for filling the missing values. Some of the data cleaning methods used for filling the missing values are like as first one is to ignore that those values which are unknown. This method is very uncompatible because by leaving those spaces we are missing a lot of data and we are missing a lot of information, and some of the queries could not process if we fill these values. I mean, does not fill these values. So leaving or ignoring the tuples for, where data is missing is not a very not a very uh, compatible method for doing our processing. The second method, that is to fill the missing value manually. If we found any missing value, then fill that manually. But this is not very practical solution because data warehouses are of very huge size of terabytes, and order to find out and to fill those missing values is not practically feasible. And the third approach is to fill the missing value with some default value or some constant values. And this is also not very easy, not very efficient approach because they may show that a lot of deviation from the original one. The fourth one approach is to fill the missing value with the average of its neighbor values. But this does not show also very exact results, and it is not always uh, possible to replace the missing value with the mean values, as there may be a lot of variation in some locations, and placing the mean value at the place where data is missing could be very different from the actual one. The most last one and the most successful one is to replace the missing value with their probabilistic value, that is find using the Bayes theorem formula, where we calculate the posterior probability knowing the prior probability and probability distribution. And this approach is the most successful one and is in practice now. That's heavily used in machine learning approaches. In data cleaning, after solving the problem of the missing values, the another problem came in front of us is the noisy data. Noise is any data which is very different from the data we expect or the data defined for that data types. For example, for the students, if we are allocating marks in between the range of 0 to 100 and by mistake some value is fitted as 200 or 300, then that will be considered as noise because it's out of the range and it will be considered as noise. For removing the noise, and for ID first we must identify that, and for doing this we use a process called the binning. Binning is the technique in which we divide our range of data into data into equal frequency equally into equal sized buckets that are called bins. And for example, in our example, the price is given as 4, 8, 15, 21, 21, 24, 25. 28, 39. There are 9 items prices here, and we have already arranged these data into ascending order. And after that, what we do, we equally partition these into bins, and as there are 9 data, and we have partitioned into 3 bins: bins A, bin B, bin C, and each in having a data, each is equally distributed and have data 4, 8, 15, and each is having a 3 data items, and the size of the bin is 3. In this way, the 4 is the minimum boundary of the bin A, and 15 is the maximum, and it may be up to 20. We may consider that. And the second bin is 21 to 24, and minimum ranges bin C is 25 to 34. This is called the equal frequency bins because each bin is having the equal number of items. Another approach of bin is used to for smoothing the data or removing the noise from the data. Here what we do, here we replace all the data item in a bin with the mean value of the bin data. As for in example, in the bin A, there are 3 data elements, 4, 8, and 15. So 4 plus 8 plus 15 is equals to 27, and 27 divided 28 divided by 3 is equals to 9 point something. So we replaced it by a mean value 9 here, and similarly in the second case the mean value is 22, so we replaced all the data items here with the mean value, that is 22, and similarly for C, they replaced each element with the mean value 29. In this way, we have smoothed our data, and most of data concentrated to a single value, and it's get highlighted, and rest other values eliminates. And another approach for smoothing is to shift to the data to the boundary or lower limit or the upper limit of the bin, whichever closer to it. For example, in our example 4, 8, 15, 4, 8 is closer to the 4 rather than the 15, so 8 has shifted to has become equals to the minimum boundary of the bin, that is equals to 4, and the data has now just 2 values, either it is the lower bound or the upper bound. So every bin is having just 2 values. In this way, the data has reduced to reduced number of distinct value, and this way we have removed some amount of noise. So we have done 2 things. We have eliminated filled the missing values, eliminated the noise, and the next comes the regression. In regression, we find out it may be linear regression or multivariable regression also, but in generally we find out an equation or formula that relate 2 variables to each other, so that by knowing one we can calculate or assume the value of the another one. If 90% of the data satisfy this condition, then we declare that these 2 variables are regression related to each other by this regressive formulas. So we try to find out the recursive formula, and on basis of which we filter out some of the data that do not satisfy that recursive function. The next comes the clustering. In clustering, the similar kinds of values are organized into group, and the data elements which do not belong to any clusters or do not find any element like them are considered as the outlier, and it is used for removing the noise. All the data which are parts of some clusters are considered as data element, and the elements which are very distinct from the rest of the elements and are not part of any clusters are considered as a noise. So that's all about the data cleaning. So in it, we have studied four things: that data cleaning, misfilling the missing values, removing the noise, regression, and clustering. So this was all about. Next topic is the data transformation. In data transformation, there are basically, we transform our data so that we get the better information about the data and precise and concise information. And there are basically 5 tech strategies for data transformation. First, smoothing, aggregation, generalization, normalization, and attribute construction. And smoothing is the process in which we remove the noise from the data. So in this way, data smoothing was a part of the data cleaning. So in this way, after removing the noise, the uh, data has least less number of distinct value, or the eliminated the outlier. So data becomes smooth, and it's also actually transform the actual data, and that's also part of the data transformation. The next one is the aggregation. Aggregation is the process in which we add on or accumulate the number of different tuples together to find out their combined values. In this is also kind of integration in which we accumulate or aggregate some particular attributes together, and this by this we transform our data into some other form, and and access them combinedly. Okay, that's called the aggregation. Another one method is the generalization. In generalization, we replace our low level data with the high level data in the concept hierarchy. For example, instead of calling car, scooter, bikes, truck, jeep, four wheeler, we can call them as the vehicles. So a vehicle is the generalization of different two wheelers, three wheelers, four wheelers, and buses, etc. So generalization is the technique in which we transform or the transform or you combined or there's number of similar kind of data at lower level to via their higher level version. Okay, that's called generalization. The next one is normalization. Normalization is the technique in which we shift our data from one range to the another or range to the another. For example, the students' marks are, if our marks are in between 0 to 100, and we have decided that we shall convert this into a scale of from 0 to 30, then the scale is, it would be said that the scale has been normalized from 0 to 100 to 0 to 30. The number will remain distinct from each other, but the total range will be shifted to a smaller range. So it will be replaced by a smaller range, and that's called the normalization. In this way, the data has transformed, but it does not has deformed its the actual data. Without deforming its actual data, it has converted to the smaller. It has converted into smaller size. The attribute construction is a set in which, by processing our old attributes, we design or retrieve some new attributes. And for example, from date of birth we can calculate the age. So a new attribute has been constructed from the date of birth. This is called the attribute construction. So in this way, the data transform contains five techniques: smoothing, aggregation, generalization, normalization, and attribute constructions. So this was all about the data cleaning and the data transformation. So I thank you all.